So we're going to find the equation of the tangent lines. This is what they look like. Mx plus b. You need two parts. You need the m, you need the b. All right, so I'm going to give you the steps. These steps always work. It's always the same steps. These are the same steps that are going to be in the notes. And I do have notes for this, and I actually have good notes for this. Some of my notes are a little spotty. So the first step, like I was saying when I was introducing the topic, we need a point that the tangent line goes through. So what you're going to do is they're going to give you an x, right? So you will be given x. They have to tell you tangent line at x equal 2, tangent line at x equal -1, whatever it is. So you're going to plug the x into the original function f of x. That's going to give you the y value. So now you're going to have a point that your line goes through. You already knew the x. You plug it into, remember, original function tells you y value. So you plug x into the original function, get the y value. Second step is just to take the derivative. I know that I'm going to need it. Why am I going to need it? The derivative tells me the slope of the tangent line at any point x. I already know my point x because it's given to me. So I need the slope. So I'm going to take my derivative. You know, step 2 and 3, you kind of do. I mean, they are separate steps. You want to make sure you take your derivative correctly. You will get tangent lines that have radicals and stuff in them. So you will have fractional exponents. So you have to know how to take the derivative correctly. If you screw the derivative up, your slope will be wrong, and then the whole problem is wrong. It's very important you're careful here when you take that derivative. Then you're going to plug x that I gave you into the derivative. So that gives you the m. Now you know your slope. So you're almost there. You got your m. You know x and y because you did that in step 1. Now all you got to do is plug them all in. You're just missing that b. The b represents the y-intercept. So step 4 is plug x, y, and m into that formula. Well, it's not really a formula. It's the equation of the line. And you solve for b. And then once you have the b, the whole thing is over, right? This is all you're missing is this dude. You're missing that number. Once you get that number, that's it. You have the line. Then you have to write the line. Usually I put a step 5 here because some people will do this step 4 and then they'll stop instead of actually writing, you know, like let's say the line was, 3x take away 5. They'll forget to actually do that part. They'll say m is 3, b is -5, and then they'll just stop. They won't, the problem says find the equation of the line. So you do actually have to write the equation of the line at the end of that. So I'm going to work an example all the way through, but it's always these steps. Always the same thing. You need a point that the line goes through. You need the slope of that line. And you need the y-intercept, the b of that line. Once you have those two pieces, really, the m and the b, you know the line. All right, let me pause. All right, here we go. Recording resumed. So here's the example to find the actual tangent line equation. So they don't, it'll say find the equation of the tangent line in slope-intercept form. I don't want to write all that out because it's too long and time-consuming, but I can type that out very easily. So I give you the function, and I give you where I want the tangent line. I want it when x is -1. So we're going to follow the steps that I just did, which the first step is to plug that number into the original function, because that is going to tell me the y value. I need the pair. I need a coordinate. I need an x and a y, or I won't be able to do this at the end. So everywhere I see x, I'm going to put -1. Now, it is easy to screw this up. If you mess up your signs and you're not careful enough, you're going to get the y value wrong, which will mess up your b at the end of this problem. So you have to be careful the whole time. Remember, you cannot hop the fence with the power on. You must do the power first. So you do -1 to the third, which is -1. A minus, that's really a -1, right? There's a little 1 there that's invisible that you don't see. I should not erase that with my finger. So negative times negative is positive. Oh man, did it come out to 0? Oh, well. I have to change this. I can't make it come out that way. I'll make this a 3. This is ridiculous. I can't have this question come out with it where the y value is 0. So I'm cheating. So poof, different problem. And I'm not going to edit it. I'm going to leave it because I can't have this being 0. So, and it was going to, you were going to have -2 plus 2. So that's no good. So I just changed this to a 3. So same thing. You do the power. You're going to times it by 3, which gives you -3. That's plus 2. So then you get -1. I don't really like that either because then the x and y are the same, but whatever. So on the test, that won't happen to you. So now I have the point. I'll do it in red. I have x is -1, and I have y is -1. That's a bad question. I get very upset if I see them being the same number. You guys know this, like on the quizzes. The numbers need to be different. So that's the point that I got after I cheated and fixed it because I made a bad question. Now, step 2 was to take the derivative. Now, remember why you're doing it. I need m. I need m. My whole goal is mx plus b. My whole goal is to make this line. So the only way that I'm going to get the m is to take the derivative, plug the number into it. The derivative tells you slope of tangent line. So the derivative of this, one at a time, multiply by the power. 3 times 3 is 9. Subtract 1 from the power. Aha. This one. Now be very careful. There is a number in front of it. When you take the derivative of something with an x, that rule was that the x drops off. So the derivative of -x is -1, right? There's a 1 in front of that x. It's invisible. You don't write it. And the derivative of this is 0 because it's a constant. So here's my derivative. All right, so I make sure it's right because if you get the derivative wrong, this whole problem is shot. So you have to be very careful there. So now I'm going to take my number. What number? The x that they gave me. I'm going to plug that into my derivative. And I'm going to compute what the m is. This is my m. -1 squared, you have to do that first. -1 times -1 is +1 times 9. Then I'm going to subtract 1. And I get 8. So that's my m. It's almost done. And make sure I'm going to run out of room here at the bottom of the board. My floor apparently is not completely even. No matter how I try to mess with that camera, it's always cutting off part of the bottom of the board. So you write y equals mx plus b. I'm probably going to do it over here so I can fit the whole thing. I now know m, right there. I know x and y, right there. I'm going to plug them all in, and I'm going to figure out what the b is. Once I do that, the problem is over. So just continuing step 4 over here. So I'll write it again. Actually, you know what? I'll write it with the m. And then I'll put the point. M is 8. That's my line. 8x plus or minus something. I have no idea what it's going to be. So now I'm going to put -1 here for x, because that's what x was equal to. I'm going to put -1 for y, because that's what y was equal to, unfortunately, which pisses me off, but what can I do? I would have made it come out to like 2 or something. So then that's -8, right? -1 times 8. Add 8 to both sides. So then b, 8 take away 1 is 7. So my line is going to be then 8x plus 7. That's the tangent line to this function at that point. If I change the function, different tan line. If I change the point, different tan line. It's going to have a different slope at any point. So this is just the tangent line for that function at that one point. I plugged into the original, got the y. Took the derivative, and then I plugged into the derivative, got the m. And then I took everything I found, put it into mx plus b, found the b, found the line. All right, here we go. So a little extra bonus here. You have radical x. Now you should all know from practicing the derivatives, you can rewrite it this way. And I'm going to show you how people screw this up because this is very easy to mess up. You multiply by the power, and then you subtract 1. These 2's are going to cross out and give you a 1. 1/2 take away 1 is -1/2. So that's your derivative. Right? You have 1 x to the -1/2. Now the question is, how you plug into it. Now I'm going to pause a second and ask everyone. Okay, so as we were just discussing, trying to put 36 into the derivative gives you this. And I have seen over the years, I would say a good 1/3 of my students got to that point before I showed them. Maybe even half of them did this part wrong or didn't know what to do with it. They would either cut the number in half. You know, some of them would put a 6 or a -6, but the problem comes from here. What you should do, even though I told you not to do it, in this case, because you're going to plug into it, when you see a negative power, you want to move it back down to the bottom, right? There's a 1 there. That 1 stays there. If that was a 2, that would stay at 2. If this was a 4, there'd be a 4 there. You know, if that was a 4, that would be a 4, right? You'd have to leave that number alone on the top. This is going to move down. Negative exponent, you move it, you make it positive. Now, the 1/2 power, I know what that means. That means square root. So in this case, and only in this case, I don't like the answers rewritten like this, but I am going to plug into it. So it only makes sense to me to rewrite it. So now when I do put the 36 into the derivative, you get 1 over radical 36, which is 1/6. So that in that case, the m, the slope of the tangent line, would be 1/6. But unless you rewrite the negative power and make it plus, and then put the root there, then you're not going to get the right value. So it's important to do that.